All right, let's jump right in. Today we're going to break down some really fascinating research about a huge goal in artificial intelligence. How do we make it not just smarter, but actually wiser?
You've seen it, I've seen it, we've all seen it. AI can do incredible things, right? It can write poetry, it can code, but it can also just confidently make stuff up or give you some of the worst advice you've ever heard. And that gets us to the core puzzle we're looking at today. How can something so powerful also have this amazing ability to fail so spectacularly? Well, these failures really point to some deep-seated issues. Today's AI, for all its power, just isn't very robust when you throw it into a new situation. Its reasoning is often a total black box. Good luck getting it to explain itself. It can be a terrible team player, and ultimately, we can't be 100% sure that it's safe.
So, what's the fix? The researchers behind the work we're digging into here suggest a really powerful solution. It's something humans have been working on for, just a few millennia. Wisdom. They make the case that wisdom is the key to solving the toughest problems that AI is up against.
Just think about it for a second. When we humans are faced with messy, unpredictable challenges in our own lives, we don't just throw raw intelligence at them. We pull on something deeper. We call it wisdom. The big idea here is that if we want to build better AI, we first have to understand and then engineer this very human quality.
Okay, so what kinds of problems actually need wisdom? The paper calls them intractable problems. And these are not your neat and tidy textbook questions with one right answer. Nope. These are the problems of the real world, where everything is messy, things are uncertain, our values are in conflict, and the rules can change on you at any moment.
Let's make that a little more concrete. You're dealing with an intractable problem when the future is just fundamentally unknowable, or when you have to trade off between two things you care about that you can't measure on the same scale, like, say, maximizing profit versus spending time with your family. The ground might be shifting under your feet, or maybe you're in a situation that is totally new, what researchers call out of distribution. In all these cases, just trying to optimize for a single right answer completely falls apart. That's when wisdom has to kick in.
So, if wisdom is the answer, how does it actually work? This is where it gets really interesting. The source material lays out this amazing two-level system that we could potentially use as a blueprint for AI. It basically boils down to this. On one level, you've got what are called object-level strategies. Just think of these as all the different tools in your mental toolbox. They're your habits, your rules of thumb, your analytical skills. But then, on a whole other level, a higher level, you have metacognitive strategies. And that is the wisdom. It's not the tool itself, but the skill of the craftsperson who knows exactly which tool to grab for which job, and maybe more importantly, when to put a tool down because it's just not working.
This diagram just lays it out perfectly. Look at how that metacognitive level is basically the manager of the whole operation. It's looking for the right strategies to use, it's stepping in when they conflict with each other, and it's watching the results to make sure we don't do something, completely foolish. It's a whole system of checks and balances inside our own heads.
And this is exactly why that meta level is so critical. As this quote from the source points out, our mental tools are always giving us conflicting advice, aren't they? Should you look before you leap, or should you remember that he who hesitates is lost? They both sound right. Without that higher level process to judge the situation, you'd just be stuck, totally paralyzed. So what are these magical metacognitive skills? Well, the paper identifies a few really crucial ones. There's intellectual humility. That's the vital ability to know the limits of your own knowledge. Huge. There's perspective seeking, actively going out and looking for other points of view. And then there's the ability to adapt when the context changes and to balance all these competing interests. This whole package, that's the engine of wisdom.
And this diagram shows the whole process in one shot. It's brilliant. Over on the left, you've got those messy, intractable problems from the real world. In the middle, you've got the machinery. Metacognition is acting like a filter, sorting through all our possible strategies and picking just the right one for the job. And the result, over on the right, is a wise outcome.
Okay, so that's the how, which brings us to the payoff. If we could actually build this kind of thinking into an AI, what would we get? Well, the benefits line up perfectly with the problems we talked about right at the beginning.
A wise AI would have 4 incredible virtues. 1, it would be way more robust, able to handle new things without breaking down. 2, it'd be more explainable, because it could actually tell you why it made the choice it did. 3, it would be a much better partner for us. And maybe most importantly of all, it would be safer.
Let's make that really real for a second. We've all heard about how large language models love to hallucinate. That's a polite way of saying they just make things up. A wise AI, one that has intellectual humility baked in, wouldn't do that. It would know the edge of its own knowledge and just say, you know what, I don't know the answer to that. That one change alone would be an absolute game changer.
And look, this goes so much deeper than just getting facts right. The single biggest challenge in AI safety is what they call alignment, making sure an AI's goals line up with our complex, messy, and often conflicting human values. And that is a classic intractable problem. There's no single correct answer. Wisdom, with its power to balance different perspectives and handle ambiguity, is exactly the tool we need for that monumental challenge.
So the vision is pretty clear, but how do we actually get there? The last step here is to look toward the horizon and think about the real, practical challenges of building these wiser machines. Now, a really critical point here is that we probably can't just throw more data at this problem and hope for the best. The researchers argue that wisdom, and especially this metacognition stuff, might require entirely new AI architectures. The way current models work, just predicting the next word in a sentence, might not be designed for the kind of deep, reflective thinking that wisdom seems to require.
But they don't just leave us hanging with the problem. They actually offer some potential solutions. This table outlines some really cool engineering ideas. Like, what if we built in explicit checkpoints where the AI is forced to stop and ask itself, how confident am I really? Or what if we designed architectures with a meta layer that manages a task layer, mimicking that human model? We could even set up a system where multiple AIs have to debate each other to stop any one of them from getting overconfident. Pretty neat stuff.
And this all brings us to one last, pretty mind-bending question. If we actually pull this off, if we build a wise AI, it won't just be a copy of us. It could operate with far fewer cognitive biases, with access to way more information. So we have to wonder, could an AI's wisdom one day actually surpass our own? And if it did, how would we, with our own limited wisdom, even know? That's a pretty profound thought to end on.